An alpha particle with a charge of 3.2 times 10 to the power of negative 19 coulomb is moving eastward into a magnetic field acting into the page, as shown below. The force it experiences is F. If the velocity v of the particle is doubled, what will be the magnitude and direction of the magnetic force it would experience in terms of F? So, formula for finding magnetic force related to magnetic field strength is B times V times Q times sine theta. F is the magnetic force in terms of Newton. B is magnetic field strength in terms of Tesla. V is the velocity of charge particle in terms of meters per second. Q is the charge of the particle. And then we have sine theta. Theta is the angle between the velocity direction and the magnetic field direction, which in this case they are perpendicular. So when they are perpendicular, it means that the theta is 1. Theta is 90 and sine theta is 1. So sine theta is 1, so it's going to be maximum B, V, Q. Now as you see here, magnetic force is directly proportional to the magnetic field strength. It is directly proportional to the velocity of the particle, and it is directly proportional to the charge of the particle. So if we make the velocity double, force will be double. If you make Q double, force will be double. If you make the magnetic field strength double, force will be double as well, because they are directly proportional to each other. So the answer is going to be 2F, 2 times F, because originally it was F. So the new one is going to be 2 times F. Now let's find out the direction of this magnetic force. It is positive, so we need to use the right hand rule. So we have the thumb going toward velocity and 4 fingers showing the direction of B, magnetic field direction, and then palm of your right hand is going to show you the direction of the magnetic force. So in this case, it's going to go up. So this is going to be the direction of the magnetic force.